In this video, we're going to show how to build a lattice part using the PartBuilder lattice physical flow, and we're going to show how to get the spreadsheet required from the lattice website. So I had a customer ask me for an LFE5U85F part. So if we go to latticesemi.com and we search the site for that LFE5U, LFE5U85. Let's just search for LFE5U. We can see that it's a ECP5 part. So what we really want to do is go find the ECP5 parts. And to do that, we're going to go to Products, and we'll go Lattice EPC5 and EPC5G. We'll click on that link. And then if we slide down a little bit, we're going to jump to all the way to the bottom. And here's the documentation section. And if we click on Pin and Package, it's going to show us all the pin and package files that are available. Now, as it turns out, that part, the LFE5U85, is really included in this ECP5U-85 pinout. So we download that. Okay. And then we have it. And then we would use PartBuilder. And we're going to set up to build this part. We're going to do a lattice physical, and then we're going to browse and we're going to find that part in downloads. And there's the EPC5U pinout.csv. It's not in the selected part folder, so it says, would you like to make a local copy? And we'll say yes, so that it copies it right to our working directory. Okay. And then what's going to happen is we're going to go read this file with this pin extract. And pin extract says, hey, there's more than one package in that file. Which one are you looking for? Now, we were looking for the 756 pin part or the 285. So my customer wanted to be able to build both. So in this case, we'll select the 756 pin one. We'll say OK. PartBuilder will read that pinout file, and it will finish, and it found 756 pins. If we want to take a quick peek at this, let's go look at that file, and we'll see what PartBuilder does with it. So we can see it's a spreadsheet with all the pins in it, and there's a column for each one of the packages that they support. So there's the 756, there's the 554, there's the 381, and there's the 285. So when PartBuilder reads this, he finds those columns, and it prompts us to say, okay, select which column you want to get the pin out from, and then it knows to take the pins that are populated from there. Okay, so if I close this and bring PartBuilder back up, so when we're in Lattice Physical, if we go to more pin report settings, once we select a package, it saves it in this Lattice package. So we'll delete that, and we'll reread it again, and now it says, okay, I'll give you another chance. So if we wanted to do the 285 pin part, we could say okay, and then it says, hey, there's only 285 pins here, so we can say fix pin numbers. And then now we're working on the 285 pin part. Okay. So let's go back and select the 756 pin part. And we'll rerun pin extract. We're going to go back to the 756. It'll complain to us again because now there's only 285 pin packages. So there's only 285 pins in our num pin setting. So we're just going to say fix the num pin settings. It'll rerun. It'll find the 785 pins. Say OK. The 756 pins is what I meant to say. So now the next step is to run SmartFrac, and SmartFrac will break the pinout up into symbols based on its. You can see it saw 8 generic I/O banks, 0, 1, 2, 3, 4, 5, 6, 7, 8. And it figured out how to break this up into symbols for us. Then we run the SDL map step, which maps the pins to the symbols, and then we run the symbol builder step, which actually creates the symbols. Okay, and then we can go view the symbols and take a look at what it created. So it created a symbol with no connects and reserved pins up front. Then it created the IO bank 0, and you can see the numbers went from 65 down to 0, so it sorted it in 65 AB, 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 all the way down to IO1 and the TDO pins. So all the bank 0 pins are here. The bank 1 pins are on this symbol. The bank 2 pins are on this symbol. Bank 3 pins on that symbol, and we can see it created 12 symbols for us in that amount of time. So we can look at the ground pins, and it created all these ground pins for us, and it found it had to create 2 symbols for us because there's so many ground pins. Okay, and then there's also the all power pins where it created the VCCs and the VCC auxes. So in that little amount of time, we built the symbols for a 756 FPGA, from downloading the pinout file to actually having symbols in our hand.